All right, when we last met, we had a ball doing something like this on our screen, where it would leave the one side and would reappear on the other side. Pretty cool, right? Well, let's say we wanted it to go the other way. So this is a little different. The big difference is we need to not start at 0. We need to start at the other side of the screen. So I'm just going to bump this up to 400, or to be at least half on our screen. And rather than plus, I'm going to use minus. So now it'll move the other way. Woo! But how come it doesn't come back? Well, our if statement needs to be changed as well. So now, when it gets to the left-hand side of the screen, the value of x is going to be really small, right? What's the left-hand edge of the screen? What's the x coordinate? That would be 0, right? The left-hand edge of our screen is 0. So what we really want to ask is, if x is less than 0, then I want x to become width. So now when I run that, it starts there and it runs across, but then we have that vanishing issue. So really, we wanted this to be -20, and we want this to be +20. So the more astute of you will notice, all I did is I swapped these two positions. I swapped this with this, and I flipped this. And then I get motion in the exact opposite direction. Not so bad, right? I could also make this move up and down by doing a y and having a y variable that went here instead of the 200. All right, but that's not really what I wanted to do today. What I really wanted to do today was think about our robot, right? We have a robot function. So right now we are calling the ellipse function right here and causing our ellipse to move across the screen. Well, what if I wanted to make my robot move across the screen? It is far easier than I bet you're thinking it is right now. All you're going to do is you're going to go to your robot function where you've got your program saved, and you're going to grab the function, the line starting with function robot. You're going to highlight all the way down to the end of your robot function. You're going to go copy. You're going to come into your animation program. You're going to put your cursor down here at the end of your draw, and you're going to hit enter a couple of times. So now we're not inside any curly braces. We're down here in empty space. Woo, empty space. And I am going to come back up to the top, and I'm going to say edit, paste. Now my robot function is inside of my animation. So now when I run it, wait, how come my robot's not drawing? I've got the robot code right down here. What gives? Well, we didn't call draw robot, right? We didn't call draw robot. So what we need to do now is, rather than ellipse, we need to call draw robot. So I'm going to go, I'm going to say draw robot. And then you've got to know what your parameters are. I have 4 parameters. Many of you probably only have 2. You probably only have x and y. So you would do something like x for the x, right? Because that's what we're using. We're using x for the x. And then you're going to use something for the y. I need to use something for the amount of green. So I'm going to make mine 100. And then I need something for the height. I'm going to make it 50. Because I have amount green and height as 2 of my parameters. If you don't have those, you would just do that if you only had x and y. I have these other parameters, so I need to put them in. And there's my robot moving across the screen. If I wanted to be a little higher, because the eye is where my robot is drawn from, I would change this number, maybe to be 150. And then, now, let's look at my robot for a second. I'm going to make this 1, and I'm going to see, when does my robot vanish? Does he get all the way off the screen before my robot vanishes? It doesn't, does it? My robot does not get all the way off the screen before it vanishes. That's a problem for me. I want it to be all the way off the screen before it vanishes and reappears on the other side. So now I've got to think about, that's where these numbers came in, these 20s. Because before, my ellipse was 40 wide. So far, so good. It would be tempting to say, oh, my robot is 100 wide. Well, that's not how my robot function works. Because remember, the form of my draw robot is x comma y comma green comma height. And that's not the total height. It's really just the height of that center portion on my robot. So this is torso height. Is really what my 4 parameters are. So what I need to know is how wide my robot actually is. So if I scroll down, when I look at my robot, I'm going to first use my thinking. When I look at my robot, it looks like the widest portion is the body portion. So even the head, even with those ears, isn't wider than the body. So I'm going to go down and find the body, find the torso. Here's my body. So we can see that my body is 70 wide. And we know it's centered on my robot, so I'm just going to, instead of 20, I'm going to make this 35, and I'm going to make this 35. And now my robot should leave the screen all the way off and then reappear just like our ball did. Not so bad. So far, so good. Now, let's say I wanted it to move up, down as well as left, right. I could do the same thing. I'm going to have to think about this. I'm going to say, let y get, I'm going to start at the top and move down. So I'm going to come down here and I'm going to write y, and then I'm going to say y gets y plus 1. And then if I run that, I should see it moving down and to the left. Very nice. But now I'm going to have a problem when he goes off the bottom of the screen because he's still going downwards. And he'll never come back. So I'm going to give me another if statement here that says if y is greater than height, again, the width variable tells us how wide our canvas is, or is set by how wide our canvas is. The height variable is set by how tall our canvas is. So I'm going to then say y gets 0. So now it should, when he goes off the bottom, he should come back at the top. Not so bad. And then since I use those width and height variables, I can actually make my canvas different, and my code should still work just fine. Let's see what happens. Very nice. Now, you'll notice he's not all the way off the bottom of the screen before it vanishes, yeah? So I have to think about that a little bit too. So for my robot, let's go back here for a second. For my robot, the top edge of my robot, so is this rectangle, right? Is the rectangle up top here. And so if I look at my robot, the head, there we go, is y pos minus 20. So that tells me that the top of my head is exactly 20 above where my robot is drawn from. You with me? So back down here, I can change this to height plus 20, and then my robot will be completely off the screen before vanishing in the downward direction. So I can just use some of those things I already determined. Now we'll be able to see it now. It'll be all the way on. Let's see. Nice. But you'll notice he's appearing way on the screen. So now I've got to do a lot more thinking to think about the bottom. So again, we're drawn from that beady red eye all the way to the bottom of that wheel, right? So if we look down at our wheel is drawn at y pos plus 30. Oh, plus, that's a different height. I shouldn't have used the word height here. That was bad. Plus the height, this is the height of my robot. That's the height of my robot. I should not have used the word height there. I'm going to call this tallness. That way, we won't confuse ourselves later. You should not name variables that, there we go. All right. So you should not name variables that use the special, so width and height, you should avoid using those. I should have known better, but I wasn't thinking when I put this together the other day. So now I just changed it to tallness. All right. So we know the bottom of my robot, I'm going to go back over here for a second. The bottom of my robot is all the way down at the bottom of the wheel, right? So we know the center of the wheel is a certain distance from that eyeball, okay? The center of the wheel is a certain distance from that eyeball, and then there's a little bit more to add. So here's the thing. You can guess and check, or you can do a little bit of thinking and arranging to find where the bottom of your robot is. Sometimes it helps to draw a sketch, but for mine, you know what? I'm not going to be able to do it easily because of the fact that I have that tallness variable in there. So I am just going to guess and check. So for mine, I'm going to make this, say, negative 50 and see how close I get. And I'm going to stop the X motion for a minute. That way I can, it's easier for me to see. So all the way off, and now I'm watching. Oh, he appears somewhat on, so I need to go a little higher. Again, sometimes the guess and check is a little easier. Since I have a variable that makes it the height, it makes it hard for me to calculate it. All right, so we're close. We're close. So anyway, what you can do, what I want you to do is you're going to take your animation code and you're going, there we go, that's pretty good. And we're going to merge it with your draw robot. Again, the thing that students are going to want to do is you're going to want to go in here and you're going to want to change this to X. Don't do that, okay? We have defined the function. Now that the function is defined, you do not have to change it. You should not change it, all right? Once the function is designed and you know it's working, you should not change it. What you're going to do is you're going to use X when you call the robot function, just like we used X when we called the ellipse function. That's the big thing you need to make sure you do. All right, so get that doing, and then we'll show you the next bit.